A bivariate map is a map that just maps two different attributes or variables of a feature at the same time. We can make a lot of different types of bivariate maps, but the ones we most commonly see are similar to a choropleth map. So they show two related attributes at the same time, and typically the way that they show those is by varying the colors. So if we have to vary two different aspects of the color at once, typically what happens is one aspect of the color to be varied is the hue, such as yellow, green, blue, and the other is the saturation or the value or how dark those colors are. So since we're varying two at once, of course the pattern across the map will have a lot of variation associated with it, and the legend will also. So these legends, in order to help organize the colors on the map, are often kind of shown as a two-dimensional grid of colors. Here's an example here of not just population density in the United States, but how the population density was changing. So we can see, if we look at the legend here, that the population density is shown here, population per square mile in 1990. The least populated areas are kind of a very light yellowish color. The medium populated areas are a light greenish color, and the most populated areas are a bluish color. But the other thing that we're showing here is how the population is changing. So if the population has stayed roughly the same or just increased slightly, up to 13%, over the last 10 years, from 1990 to 2000, then it would be a medium yellow, a medium green, or a medium blue. If it's grown even more quickly, we can see now we get into a rich or saturated and slightly darker yellow, green, and blue here. And the lightest colors mean that they've actually had a population loss. So even areas with high population can have a population loss, or areas with very low population can have a population loss. Now we're really getting into some patterns here. We can see that areas like Florida have a high population density and they have a growing population. Areas like Pennsylvania have a high population density, but they're actually losing people. And areas like parts of the Midwest out here started out with a low population density and they're losing even more people. So both by the different hues that are represented on this map and how richly saturated the colors are, we're showing two different variables, population density and change in population, all at the same time. This is a similar map having to do with diversity. So what we can see here is this one is just kind of turned on its side, but we're going from high diversity in blue here, all the way from blue to a lighter blue to a lighter blue to almost a white. And then we're going, as we get these darker colors, we're going to low diversity. So high diversity here, low diversity over here. But the other thing that's changing as we move from here to here is that there's little change in the diversity with these bluer colors, and a lot of change in diversity, a large increase in diversity with these yellower colors. So some areas, like for example, the areas in bright yellow here have low diversity, but a big increase in diversity. So that would be areas like the Midwest and up through this portion of the Appalachians. And areas that have high diversity or little change, they would be areas like the South and California and those areas here. So once again, two different things shown on this map. It reveals patterns we wouldn't see by just looking at one of those, and it's a nice way to represent a lot of information on a map using colors in an effective manner. I showed this map before. This is a map of Bigfoot sightings, and Bigfoot sightings, they could be because people really are seeing Bigfoot or think they've seen Bigfoot, or it could just be because a lot of people live in a certain area. So if you get a lot of people, the odds are higher that at least one of them is going to see Bigfoot. So just looking at the Bigfoot sightings, it looks like they happen in areas like all through the Pacific Northwest and into California, all kind of through the eastern and southeastern United States. But what if that data is really meaningful? One thing we could do is we could compare this to how much population density there is in an area and see how big of an effect that's having. So we're going from a point map here to something that's going to be a bivariate choropleth map, which is shown here. we have high sightings shown in purple here, and rare sightings would be shown in green here, given the amount of population in a particular area. If we get just about as much sightings as average we would expect for a population, it would be shown in this light blue here. And if we get fewer sightings than we would expect given the population living in an area, we would get this color here. So what we can see here in the Pacific Northwest, the maybe not so much right in the area where the bigger cities are, but out in this area here, the sightings are higher than we would expect. A lot of sightings per population, and over in the eastern United States, sightings are more rare. There's more people living over there, so there might have been more dots on that previous map, or there might have been a lot of dots on that previous map, but they really are fairly rare here. And in some cases, we get areas like southern Florida, where, yeah, given the amount of population we have there, I would expect at least some of those people to call in Bigfoot sightings, whether they really see anything or not.